First Coast Math Clinic with Lesson 3, Negative and Zero Exponents, from Unit 10, Exponents, from our Pre-Algebra and Algebra curriculum. So the goal in this video is to identify and apply properties of negative and zero exponents. And we're going to start with negative exponents, and a little bit later in this video, we're going to get into zero exponents. Then we'll do some examples that combine both negative and zero exponents. And to start with negative exponents, we're going to review the quotient property. And quotient property is from Lesson 2. So if you want to review the material from Lesson 2, the link for the video is going to come up right now. But our quotient property basically says if we're dividing two terms that have the same base, so a to the m divided by a to the n, to simplify that, we're going to subtract our exponents. So a to the m minus n. That's how we're going to simplify this. So as a review, if I have x to the 7th divided by x to the 2nd, to simplify this, well, let's think, like, where do we have more x's? We have more x's in the numerator. So this is going to be x to the 7 minus 2, which is x to the 5th. Okay. Well, if I want a negative exponent, well, where does the negative exponent come from? Well, we can get a negative exponent by, instead of doing 7 minus 2, by subtracting 2 minus 7. And if we do 2 minus 7, then our term winds up going in the denominator. So this is going to be 2 minus 7. We'll put 1 as a placeholder in the numerator. And this is 1 over x to the negative 5th power. Well, what's the relationship between these two terms, right? Here and here, right? We get the same thing. We get a problem with our negative exponent, 1 over x to the negative 5th. We can rewrite it with a positive exponent by just bringing it up to the numerator, x to the 5th. And that's the property that we're going to be using when we work with our negative exponents. So our rule with negative exponents is negative exponents can be rewritten as its positive reciprocal. Okay, so we've got our 1 over x to the negative 5th. We're making the exponent positive, and we're bringing this x to the negative 5th up to the numerator. So let's look at a couple just basic examples, right? So if I have 1 over x to the negative 3rd, put that over 1, and I can rewrite it as 1 over x to the positive 3rd, because that x to the negative 3rd is going to go down to the denominator to make it positive, right? So the positive reciprocal, so I'm rewriting that negative exponent as its positive reciprocal. And what if I have something like this, 2 over y to the negative 4th? Well, what is that negative exponent on? That negative exponent of 4 is just on the y. So we could think about this as maybe like 2 times 1 over y to the negative 4th, if you want to think about it like that. Right, so this 2 here is going to stay where it is, right? It doesn't need to move because it already has a positive exponent. But this has to move because it's got a negative exponent. So I'm going to rewrite this, keeping that 2 where it is. I'm going to bring this y to the negative 4th up to the numerator. It becomes y to the 4th, and my answer is 2y to the 4th. Okay, so let's get into a couple examples where we simplify expressions by making our negative exponents positive, and then using some of our quotient properties from Lesson 2 and multiplication properties from Lesson 1. For 1, we have x to the negative 9th. So again, just to do this out, I can put this over 1, so we can clearly see what we're doing. All right, so we've got x to the negative 9th. I want to make that negative exponent positive. So when we simplify the expression, we want to make all of our negative exponents positive. So to make that negative exponent positive, I could take this entire term here, bring it from the numerator to the denominator. I'm going to replace this with 1. And And when I bring that x to the negative 9th to the denominator, that negative exponent becomes positive. Number 2, the negative 2, exponent of negative 2 is on the z. This 4 doesn't have a negative exponent, so it's going to stay where it is. So I can put everything over 1. So I'm just moving that z to the negative 2nd to the denominator. So my answer is going to be 4 over z to the 2nd. And number 3, x to the negative 5th. So my negative exponent is on the x. I want to bring that up to the numerator to make that exponent positive. This 6 has a positive exponent, doesn't have a negative exponent, so it's going to stay where it is. So to simplify this, I'm going to write this as 6x to the 5th power, because I'm literally taking this and bringing it up to the numerator. Let's do a couple more examples where we simplify expressions by rewriting and getting rid of our negative exponents. So for number 4, I've got x to the negative 5th over x to the negative 7th. Well, both of my bases have negative exponents, so I'm going to have to move this term, x to the negative 5th, to the denominator, and I'm going to have to move this term up to the numerator. So this is going to be rewritten as x to the 7th over x to the 5th. Now, I'm dividing my bases, so we can use our quotient property, keep our base, subtract our exponents, x to the 7 minus 5, which is going to give us x to the 2nd power. All right, number 5, we've got a number of terms with both positive and negative exponents, x to the 3rd, y to the negative 2nd, z to the 5th, over x to the negative 2nd, y to the 5th, z to the negative 7th. So let's start just by rewriting this expression with only positive exponents. So starting with our x's, this x is positive, it's going to stay where it is. This exponent here is negative, it's going to move up to the numerator. All right, let's look at our y's. This y has a positive exponent, so it's going to stay where it is. This y has a negative exponent, so it's got to move to the denominator. And when I move it, the exponent goes from negative to positive. This z has a positive exponent, so it's going to stay where it is. This z has a negative exponent, so it's going to move up to the numerator. So now we're multiplying. Let's use our property of multiplying our property of multiplying our bases. When we multiply our bases, let's add up our exponents. X to the 3rd times x to the 2nd gives us x to the 5th. We multiply our bases, add the exponents. Z to the 5th times z to the 7th gives us z to the 12th. And then y to the 5th times y to the 2nd gives us y to the 7th. So this is going to be our final answer. For example 6, we've got an expression inside a set of parentheses and then a negative exponent outside of the parentheses. So what I like to do here is let's simplify everything that's inside the parentheses and then take care of that negative exponent last. So there's a couple ways, different ways you could do this. I'm going to simplify everything inside the parentheses first and then take care of the negative exponent last. So let's start with just by rewriting this, getting our negative exponents positive, as well as simplifying the 2 over 6. So we've got 2 over 6. We know that reduces to 1/3. Now our x's, x to the third and x to the negative 6th. X to the third is going to stay where it is. My exponent here is negative, so it's going to move up to the numerator. Our y's, all right, this y has a positive exponent, so it's going to stay where it is. This y has a negative exponent, so it's going to go down to the denominator. And we move it, the exponent becomes positive. So now when we simplify this, all right, 2 over 6 simplified to 1/3. X to the third times x to the 6th becomes x to the 9th. And then y to the 5th times y to the 4th becomes y to the 9th. I'm going to rewrite this down here so I have a little bit, or over here so I have a little bit more room. X to the 9th over 3 y to the 9th. All right, I don't need to rewrite that 1. And now let's put back that negative exponent of 2. So we have the quotient to a power property, so we can distribute that power in. Now we have the power to a power property. So power to power, we want to multiply our exponents. So we're going to get x to the negative 18th, 3 to the negative second power. I'm going to keep that 3 to the negative second power for right now. Y to the negative 18th. And now we've got everything with negative powers. So let's rewrite this with positive exponents. So all we have to do to rewrite it with positive exponents is just flip everything, right? So my x to the negative 18th goes to the numerator, or goes to the denominator, excuse me. 3 to the negative second goes to the numerator, and y to the negative 18th goes to the numerator. So when we rewrite things, we should have 3 to the second, y to the 18th, over x to the 18th, and 3 to the second is 9, y to the 18th over x to the 18th. And that's going to be our answer. So I chose to simplify everything inside the parentheses first. If you decide to kind of use this quotient to a power property first and distribute that exponent first, you could do that as well. I like to simplify everything as much as I can and then take care of that exponent. Both ways would work. But our final answer here is going to be 9 y to the 18th over x to the 18th. All right, well, let's go through a couple examples with the zero involving the zero exponent. So let's look at the zero exponents. So I have 2 to the third over 2 to the third. And our quotient property, we know that if we have the same base and we're dividing, we can basically just take our base, keep our base, subtract our exponents. So this is going to give us 2 to the 0 power. Well, what is that equal to? Let's think about this a different way. So if I have 2 to the third over 2 to the third, well, 2 to the third is 8 and 8. I have the same numerator and denominator, so 8 over 8, whenever I have the same fraction with the same numerator and denominator, that's just going to be 1. So it makes sense that everything here, also has to equal 1. So that's where we get our zero exponent property from. Anything to the 0 power is 1. So it makes our work a little bit easy to do, pretty easy to do. So if I get x to the 0 power, that's going to give me just 1. Parentheses, negative 5 to the 0 power is 1. 123,456, doesn't matter how big the number is to the 0 power, is going to give me 1. Let's go through a couple of examples where we combine negative and 0 exponents. So number 7 is a to the negative third, b to the 0 power, c to the negative ninth, over a to the negative fifth, b to the negative fourth, c to the 0 power. So let's start by rewriting this, getting rid of our negative exponents. So starting with our a's, a to the negative third, let's make that exponent positive by bringing it to the denominator. So it becomes a to the positive third. And b to the negative fifth, let's make that exponent positive by bringing it up to the numerator. So it becomes a to the positive fifth. Looking at our b's, we've got b to the 0 power, so we know this is going to become 1. Anything to the 0 power is 1. So I'll put 1 in as a placeholder. And b to the negative fourth, that's going to go up to the numerator to make that exponent positive, so b to the fourth. Looking at our c's, c to the negative ninth, that's going to go to the denominator to make that negative exponent positive, so c to the ninth. And then c to the 0 power, that's going to become 1, so I'll put 1 in as our placeholder. Now let's simplify our a's. We've got a to the fifth over a to the third. We know from our quotient rule, when we're dividing our bases, we want to subtract our exponents. So this is going to be a to the fifth minus 3, which is a to the second power. So that's going to go in our numerator. So we'll have a to the second. We don't need that 1. So we'll keep the b to the fourth. We have nothing to reduce b to the fourth with. And then our denominator, we're going to keep the, shouldn't be a, should be c. C to the ninth. So we'll get a to the second, b to the fourth, over c to the ninth. So that was number 7. So this was lesson 3, negative and 0 exponents. If you like this video, leave a like, comment, and subscribe. First Coast Math Clinic.